Here we go, number 11. I'm going to stream through this. This indeed, again, is an improper integral. We're going to rewrite this as the limit as a approaches negative infinity of the integral from a to negative 2 of 2 over x squared minus 1 dx. We recognize this as, like, is this, it's either we're going to do partial fraction on this or it's going to be inverse tangent. I'm trying to remember what's the form for the.
I don't think it's inverse.
Is inverse tangent a plus?
It's a plus.
Inverse tangent is a plus, so we're going to have to do partial fraction decomp on this.
Yes, I love.
All right, so 2 over x minus 1 x plus 1 is equal to a over x minus 1 plus b over x plus 1, which means we have 2 is equal to a x plus 1 plus b x minus 1. If we let x equal to negative 1, the a part goes away, and we get 2 is equal to negative 2 times b, or b must be negative 1. If we force x to be 1, the b part will go away, and we get 2 is equal to 1 plus 1, 2a, or therefore a must be 1. So we end up getting 1 over x minus 1 plus, minus 1 over x plus 1. Bring that back. So this becomes the limit as a approaches negative infinity of the integral from a to negative 2 of 1 over x plus 1 minus 1 over x minus 1 dx. Now I want to just make double sure. Is this function defined on this interval? Well, if a is really small, and we go up to negative 2, and the first discontinuity is at negative 1. So we are this function is continuous on that interval. I just want to make sure that, because that's going to play into our second part of the lecture.
You switched the plus and minus when you brought it back.
Did I? I did. Don't do that. Although I think in this problem it's not going to matter, but we should write things correctly.
Minus.
There we go. So next step is finding that antiderivative, and we're going to get the natural log of x minus 1 minus the natural log of x plus 1. By the way, these are all absolute value signs. And we're going to evaluate that from a to negative 2. That's so far so good? Right? So let's evaluate at our limits of integration. So we get natural log of negative 2 minus 1, that's negative 3. So it's going to be the natural log of 3 minus the natural log of negative 2 plus 1, which is negative 1, absolute value of that. So that's going to be the natural log of 1. And now let's do it at the low end, which is going to be natural log of absolute a minus 1 minus the natural log of absolute a plus 1. So far so good?
Yeah.
All right. Cleaning up. The limit as a approaches negative infinity. Kept on dropping my negatives there. This is 0. Let's not write that. The natural log of 3 minus. Now, these are two natural logs, and we've got a subtraction. I think I could rewrite this as the natural log of the absolute value of a minus 1 over a plus 1. Now for the big step. As a goes to infinity, this fraction right there goes to 1. As a goes to infinity, the plus 1 and the minus 1 are negligible. So this is going to end up being the natural log of 1, and the natural log of 1, as we've already discussed, is 0. So when we apply the limit, we end up just getting the natural log of 3. And that's what they say The answer is. So it does converge, and it converges to the natural log of 3. I'm so glad.